Continuing lesson 4.3 on simplifying expressions, page 203, example 3. A difference on this problem is that there are two variables. The idea is the same. We're just going to look for like terms here, try to combine those together to simplify this. So first of all, if you want to, you can rearrange and get your like terms next to each other. Usually what I'll go ahead and do before anything else is to add the opposite anytime where they're subtracting. And then, like I said, it's up to you if you want to rearrange. If that's helpful to you, then go ahead and do that. If it doesn't seem to help you any different, then you can just keep them in this order. Since we're all adding these all together, we can do this addition in whatever order we want. So we're just going to pick out our like terms. So with the A's, we have 4A plus negative 3A would be 1A. With the B's, we've got negative 5B plus 2B, which would be negative 3B, or you could say plus negative 3B if you want. I forgot to add the opposite here, which we wouldn't have to do. So you could have plus negative 6 there, or just minus 6. So you could either have what I have, or if you don't have the adding the opposite parts, then you could have like 1A minus 3B minus 6, or just A minus 3B minus 6. So if you look at the try it, same idea. I'm going to go ahead and add the opposite over here on that last term. The first term we don't have to add the opposite. It's a negative 3.7 just at the beginning. So it's only if we have subtraction later on in our expression that we'll add the opposites. Usually if there's more than one variable, what they do is they go alphabetical order. So in this case, G comes before K. They usually start with the variables and then do the constants at the end. So we've got 5G minus 10G, or plus a negative 10G. If you want to fill in the blanks here, we can. So those are working against each other. We have more negatives by 5, so that's a negative 5G. The 4K is the only K term that we have, so that just comes down. And then we've got negative 3.7 plus 11.1. Those are working against each other. They're battling it out here. We have more positives, so we'll subtract, which would be 7 4/10, and we have more positives. Whoops. This would be negative 3 7/10 if you were filling in the blanks, and then that would be 7 4/10. Okay, so this would be our expression, and then you could just rewrite the same thing in there if you wanted to. That would be our answer for that problem. So if we look at the do you know how, number 4. So for simplifying this, I'm going to go ahead and add the opposite anywhere where they're subtracting. We have more than one variable. First, alphabetically, would be B. So negative 4B plus negative 3B, they're working together this time. That would be negative 7B. We only have one K term, so you can put plus negative 9K. And then we've got negative 6 plus 12. They're working against each other, so we'll subtract. Subtract, you get 6. You have more positives, so that would be a plus 6. One thing, if you want to, like the book did, if you want to put parentheses around the negative 9K, just so it doesn't blur in with your addition sign. And like I said, you could otherwise just have minus 9K. Those are equivalent expressions. When you get your final answer, just make sure that you don't have any like terms still that you forgot to combine together. We have a B term, we have a K term, and we have a constant, so we should be good. Number 5, one spot we can add the opposite right here. And then we only have one variable, which is Z. Combine those together. Some are positive, some are negative. So they are battling it out here. We have more positives. You can put a 3.20 or just 3.2z. And again, I usually write the line through my z so it doesn't look like a 2, even though I don't write my 2's that way. And then -2 plus -6 would be -8. So you can write it like that, or you could say 3.2z minus 8. Number 6, we can add the opposite at the end here. -1/3 plus -4/3 would be -5/3 y, and you can just leave it like that since we can't reduce. We could put -1 2/3 y if you'd like. And then -9 plus 6, there are different signs, so they're fighting it out. And we subtract and we get 3. And we had more negatives, so you could either put plus -3 or you could just put -3. Workbook page 49, we'll look at a few problems here. One thing just to mention, if you were doing a problem like number 1, we haven't seen much of this yet. Those are like terms we can combine together, and we would just get 8m, and that would be it. So it's possible to have only one term as your answer. Normally not going to be the case, but it is possible. If we look at number 7, which expression is equivalent to that? So let's go ahead and just combine like terms. We don't have any subtraction here for adding the opposite. -2v plus -3v would be -5v. And then -4 plus 8. Those are working against each other because they're opposite signs, so subtract is 4. We have more positives, so -5v plus 4, and that matches up with answer choice D. Look at number 15. They want us to explain whether those are equivalent. So to see whether they're equivalent, we're just going to combine our like terms. For this first one, you can go ahead and add the opposite on those. The t's you can combine, so 8t plus -4t, opposite signs, different signs, take the difference. We have more positives, so that's 4t plus -3y. And then if you look at the other expression, same idea, you can add the opposite here. Combine these together. They're different signs, take the difference. You have more positives, so that would be 4t plus -3y. And look again what we had on the other one. We had 4t plus -3y. So the question is whether they are equivalent. And the answer is yes. So we could just say something like yes, or yes, they are equivalent, because both expressions simplify to the same thing. And finally, if we look at number 17, which of the expressions is equivalent to that? So same idea here, we can add the opposite, combine like terms. So 12x plus 2x would be 14x. And then -3 plus 13, different signs, take the difference. We have more positives, so that would be plus 10. So 14x plus 10. I see the second one is already like that. Basically, then we're just looking at if there's anything else. Nothing else is exactly looking like 14x plus 10. You could look for 10 plus 14x. That would be the same because commutative property, change the order. The last one, the last option here, we do have an option of distributing. So if you try and distribute that, that would be 14x plus 10, and that's what we had. So that would be another option that would work there. So this gives you an idea of how to simplify expressions. Have a good day.